Okay, so we're on. So when we do simple probability, we're doing favored outcome over the total outcomes. So in this case, our favored outcome is not getting drink A. So how many ways are there not to get drink A?
20.
No, there's 20 ways to get
50,
drink
or
A.
30, 40, 30, something like that.
Wait, would you just, what?
Olivia, what did you say? 30. There's 30 ways of not getting drink A, because there's 20 samples of drink A. There's 10 plus 10 plus 10 samples that are not drink A. So there's 30 total, or 30 ways of not getting A. How many total outcomes are there? 50.
You got me on
So the probability is 30 out of 50, which simplifies to,
Something.
it's got zeros on the end. It's really easy to simplify. Just knock the zeros off.
3 and 5.
3 out of 5.
I'm
So the
still
probability
fine.
is 3 out of 5. You can express probability as a fraction like this, as like a ratio, or you could express it as a percent.
Is that all we do?
If you wanted to, you could do 3 divided by 5, and you could say there's a 60% chance that you won't get drink A.
Is this all?
Yeah, this is all for this. Now, we're going to do compound probability today, so we're going to take this beyond simple probability.
I like
If there's a
simple more.
60% chance of not getting drink A, what's the probability that you're going to get drink A? 40. Good. All right, let's look at number 2. After receiving complaints, the skateboard manufacturer inspects 1,000 skateboards at random. The manufacturer finds no defects in 992 skateboards. What is the probability that a skateboard selected at random has no defects? Write the probability as a percent. How would we do this? What?
I move up to there.
Yeah, you can move up there, sure. Easy, what did you say?
1,000 minus 992,
Not quite. Remember, we want our favored outcome over the total
So
outcome.
what our favorite outcome is 992.
Good,
And over 1,000.
good.
And then you figure whatever the heck that is, I have no idea.
Yeah, well, let's pull out the calculator. 992, whoops,
That is
it's
a
not
big number.
992.
And
Start again. 992 divided by 1,000 is 99.2%.
Oh, 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 oh.
So that's a pretty good, it's a pretty good percentage. 99.2% of the time, you're gonna get a good skateboard. That other 0.8%, you might get one that has a defect.
Okay, now what's the other thing here? Or wait, were these both two simple ones? I thought you said that was a simple one. that
No,
was
they're both
compound. I was
simple.
like, I don't-
Today,
I
we're
don't
gonna
wanna
do
that.
compound.
Should do it Monday. I like these simple ones. They're easy.
Well, we'll be practicing a lot of simple within the compound, so, not too bad. Okay, these are the warm-ups for the next couple of days, so you can pull this out. We're not gonna do this whole flip chart today. So the objective for this lesson is to find probability of something called mutually exclusive and overlapping events. That's what we're gonna talk about today. Objectives 2 and 3, we're gonna talk about all, probably on Monday. Maybe it'll take Monday into Tuesday to finish those. Okay, just move this little thing out of the way. There we go. So a compound event is just 2 or more events linked by the word and or the word or. So you might have something like, what is the probability of getting heads on a coin and rolling a 6? Probability of getting heads and rolling a 6. That's an and. You want both of those things to happen at the same time. You could also have an or kind of probability where you have something like the probability, say you're rolling a die, and you want to know the probability of rolling a 2 or a 3. Now, there's two types of events that we're going to be talking about today. We're going to be talking about the or kind. So we're going to be doing or. Mutually exclusive events. There's another word for mutually exclusive. They're also called disjoint events, and it's actually a little easier to remember if we call them disjoint because it just fits what they are a little better. So right underneath this, disjoint. Your textbook uses mutually exclusive. I think the next time I teach this, the next time I'm going to redo all the slides, I'm just going to use the word disjoint and throw in mutually exclusive later because this word is a little confusing. Disjoint events have no outcomes in common. And the word disjoint kind of makes sense. Like disjoint sounds like things wouldn't be together. Mutually exclusive, you see that word mutual in there and you think maybe they should have things in common, but they don't. They're exclusive, so they don't. But, so disjoint or mutually exclusive means they have no outcomes in common. So, for example, this one that we did up here, the probability of rolling a 2 or a 3, you can't roll a 2 and a 3 at the same time on one dice, right? So those events are disjoint. Another example would be getting, let's see, spinning, if you're spinning on a spinner, spinning a 4 or a 5. You can't spin a 4 and a 5 at the same time. I get it, you can be on the line, but you can't be exactly on the 4 or on the 5 at the same time. So there's no outcomes in common. If there are no outcomes in common, the formula is really easy. We say that the probability of event A or event B equals the probability of A plus the probability of B. And that makes sense, because if I ask you, if we go back to rolling a 2 or a 3, there's one way you can roll a 2 on a die. So the probability of that would be 1 out of 6. There's one way you can roll a 3. So to get either of these outcomes, there's two different ways. You could roll a 2, or you could roll a 3. 1 6 plus 1 6 is 2 6. Okay, next type are overlapping events. The word overlapping makes sense. If things are overlapping, they overlap. They have at least one outcome in common. So disjoint or mutually exclusive have no outcomes in common, but overlapping events do. So if you were to say, what is the probability of spinning a multiple of 2 or 3 on a spinner? Multiple of 2 or 3. Are there any numbers on a spinner that might be multiples of both 2 and 3? Can you think of any? 6. 6 is a multiple of 2 and 3 at the same time. What else? Just 6. Yeah, if you're talking about a spinner that's a 10
Do you want that
section
as
spinner.
2 or 3, or is it 2 and, it's just or?
Yeah, it's
Okay.
still or, but it's spinning a multiple of 2 or 3. Okay, and the formula of this is a little more complicated. In this case, we still add together the probabilities, but because they overlap, so see how my arms are like this, okay? If I add together all of this arm plus all of this arm, there's going to be this region where they overlap. So I have to take away one of the parts of data from that part. So we have to subtract the probability that it could be both. So if I had a 10-section spinner, let's see if I can do this one. That's not too bad. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, how many of those numbers are a multiple of 2? 5 of them. So it's 5 out of 10. That over here, 5 out of 10 would be a multiple of 2. How many are a multiple of 3?
No.
Yeah. Think about counting numbers.
2.
Well, let's circle what they are.
All right.
3 is a multiple of 3, right?
We have 1, 9,
What else?
also
9. What else? There's another one. 6. Okay, so we have 3 out of 10. Let me actually go back with green and circle our multiples of 2. So we ended up circling the 6 twice. So it's an overlapping one, so we have to take away one of the 6s that we counted. We counted the 6 here on the 5, we also counted it on the 3, so now we have to take it away. Minus 1/10. There's one chance out of 10 that it would be both. Does that make sense? Why we take that away?
Yeah.
Okay, so adding these together, remember when we add fractions, the denominator stays the same. We have 5 plus 3 is 8, minus 1 is 7, so our probability for that would be 7/10. It's a pretty good chance. Okay, now we're going to take a look at an example. Did you guys all get this? You good now? Okay, so objective 1, we're going to actually practice finding probabilities of mutually exclusive and overlapping events. Suppose you spin a spinner that has 20 equal-sized sections numbered from 1 to 20. What is the probability that you spin a 2 or 5? So first of all, I asked the question mutually exclusive. It might be easier to think, is this disjoint or overlapping?
So for this, it would just be find the multiples of 2 and 5.
Mm-hmm.
All we have to do is find where they overlap.
Yeah, do they overlap? Are there any numbers, and this, it's not multiples here, it's just spinning a 2 or a 5. Is there any overlap there? No, a number can't be 2 and 5 at the same time. So they are disjoint, which you could also say is mutually exclusive. So which formula are we going to use? Okay, good. When we say that, we say probability of A or B.
Your probability of A would
Okay.
be equal to probability of A plus probability of B.
Good. Okay, Julia, what is the probability that we're going to spin a 2? What? Well, how many 2s would there be on a spinner that's from 1 to 20? How many just 2s?
Multiple of 2, you say?
No, not multiples, just 2. Is there more than 1 2? No, there's just 1, right? 1 2 out of 20 possible things we could spin. So our probability of spinning just a 2 is 1/20. Olivia, what's the probability that we're going to spin just a 5? How many 5s are there on our spinner? Imagine a spinner from 1 to 20. Don't overthink this. It's not a trick question. One, just one. So our probability, again, is 1 out of 20. So adding those two probabilities together, we get 2 out of 20, which reduces to what? 1 over 10. Good. Okay, now the next one is a little trickier. What's the probability that you're going to spin a number that is a multiple of 2 or 5? Is this disjoint or overlapping?
It would be overlapping.
Overlapping, why? Good. There are some numbers that are multiples of both.
Could be 10.
So we need to use our long formula. Probability of A or B is going to be the probability of event A plus the probability of event B minus the probability that they happen at the same time. Okay, so what's the probability that a number is going to be a multiple of 2? How many multiples of 2 would there be on our spinner? Now, Mrs. Murray, we get to do the multiples.
I looked down at that problem when you were doing, I'm like, multiple.
Garrett,
What?
what's the probability that it's going to be a multiple of 2?
10?
10.
Over 20?
10 out of 20, good. Casey, what's the probability that it's going to be a multiple of 5?
What? 10, 5, no, something.
Count by fives and think how many of those
5,
fit.
10, 15, wow, 4.
4, so we've got 4 out of 20. And when we're adding these fractions, it's better not to reduce the fractions because we want this common denominator. All right, now, volunteer for this one. How many of the numbers? Think about, it's easier to think about this. How many of them are multiples of both? 2, good. Because we've got 5, 10, 15, and 20. 10 and 20 are also multiples of 2.
So we're not solving this now, we have to do a minus something, which is.
Minus 2 over 20. So we have 10 plus 4 is 14, minus 2 is 12 over 20. And what does that reduce to? 6 over 10, which reduces to? 3/5.
Casey's got it, I was going too far.
3/5.
I was trying to assist, but then you were catching on, so I said it.
Okay, any questions? Or you can move
Here we
on.
get the 2 over 20, real quick.
The 2 over 20?
Yes.
Because we're looking at how many numbers, here's the multiples of 2. We've got 2, 4, 6, 8, 10, 12, 14, 16, 18,
20.
and 20. Multiples of 5 are 5, 10, 15, 20. The 10s are in both groups, and the 20s.
Well, you did it, you did it.
There we go, the 20s are in both groups, so that's where we got the 2. There's 2 of
Two
them
groups.
that are in both.
Gotcha.
So we counted them twice. We counted the 10 here, we counted it again here. So that's why we have to take it away, because we counted it twice. So I have to take away one
Okay,
of
I
those.
got you.
Make sense?
Yeah.
Okay, the next one says you try, but we're gonna do it together. Suppose you roll a standard number cube. So how many sides does a standard number cube have?
The standard cubes.
Yeah, just like a dice.
6.
6, okay. What is the probability that you roll an even number or a number less than 4? Would these events be disjoint or overlapping?
It'd be just, no, it'd be
It's
overlapping.
Overlapping, why?
You got 2, wait. You only roll
Because
2
you can roll an
fours.
even number, or you can roll a 4, you can get a 4 from the.
Yeah, or 2.
Or a number, well, it's less than 4. But
So
yeah, a
a
2
two.
would
Two.
fit both.
You'll
Good,
do
good.
2.
So it's not mutually exclusive because it's overlapping. A number can be even and less than 4. Julia, tell me what formula I'm going to use. You can look at your notes, you don't have to look at my notes. The more we write it, though, the better we're going to remember how to do it. So we have, I'll start it for you, we have probability of A or B equals what? We can call it probability of A.
Are those
Okay,
plots?
probability of A, good. Yeah, we do have to do the minus. What?
Probability of A.
Good, minus the probability of A and B, so we have to get rid of the overlap. Okay, so what's the probability first that you're gonna roll an even number? Olivia? How many even numbers are there on the die? No? You've got 2, 4, and what? 2, 4, and 6, right? Your even numbers. So you've got, what probability would that be? 3 out of, you know, how many numbers are there on the die? That's what we want on the bottom. There's 6 numbers on the die, so we have 3 of them are even out of 6 altogether. Got it now? Okay, how many numbers are less than 4? We're not actually gonna simplify it yet. It's easier to add them if we don't. 3 out of 6 again. Now, how many numbers are even and less than 4? What are they?
I mean,
never mind,
one, just
one.
two.
One,
There's
okay.
no, there's
Yeah.
no zero on that.
Right, right. So 1 out of 6. So we have
Took
3
us a
plus 3
second,
is
but we did
6.
it.
Minus 1 is 5, so the probability is 5, 6. Okay, let's look at the next one. What's the probability that you roll a 2 or an odd number? Is this one disjoint or overlapping?
Disjoint.
Disjoint, why?
Because, I don't know, I'm trying to remember.
It's
Is it
overlapping
actually
because you can
disjoint?
roll a 2 and you can get, 5. I don't know.
Right, but
is it
can a
disjoint?
number, it is
No, it
disjoint.
cannot be an odd
Can a
number.
number be 2 and odd at the same time?
No.
No, so it's disjoint.
Okay.
Or mutually exclusive, yes. It is disjoint. Let's put that word in there too. So we're gonna use the easy formula. Probability of A plus probability of B. I'm pretty sure that you don't get these formulas on the Keystone sheet. I don't think they give you any probability formulas. I'm gonna probably give you that formula sheet next week, so we'll know. All right, Julia, what's the probability that you're gonna roll a 2? What? 1 out of 6, good. Casey, what's the probability that you're gonna roll an odd number?
Out of the 4? Or no, out
No,
of all 6?
Out of all 6, yeah,
3.
3. Garrett, what do we get?
4, 6, so also reducing 2 and 3.
Good.
A long time.
Still about 60 minutes.
Okay, next set of problems talk about drawing a card from a standard deck. So let's talk about a deck of cards for a minute.
52.
52 cards, what else do we know about a deck of cards?
There's like 2 jacks, two of everything. Come on.
No, not 2
No.
of everything.
There's 4 suits.
There's 4 suits, what are the suits?
Clubs, hearts, diamonds, spades.
Mm-hmm. Clubs, hearts, diamonds, and spades.
Okay.
So there's 4 suits.
That's 10.
How many colors are there?
4.
2 colors.
Oh, wait,
No,
yeah.
only 2 colors.
What kind of cards you playing, man?
Yeah, I'm playing Uno.
Yeah, Uno has at least 4 colors.
Probability, you know.
Why is this an Uno question? We cut out this.
I should make an Uno question.
We should play Uno.
Okay, so we're drawing a standard card.
Okay.
Okay, and then face cards are usually considered like jacks, queens, and kings are face cards.
Yeah.
What numbers does it go up to? We have aces through
10.
10, highest number. Okay, so we had to know all that to make sure we got this straight.
You should
First
have
of
like
all-
a standard deck excluding face cards.
Well, we want face cards. First
Really?
question has face cards in it.
Yeah.
There's one worksheet you're gonna do where they count aces as face cards, but they tell you that. Most don't. All right, so what's the probability that you're gonna draw a jack or a queen? Are those events disjoint or overlapping? Olivia, what do you think? Can a card be a jack and a queen at the same time? No. So does that make them disjoint or overlapping? No? To be overlapping, they have to be the same thing at the same time. So this would be disjoint, which makes it the easy formula. Probability of A or B equals probability of A plus probability of B. Okay, so what's the probability that you're gonna draw a jack? Garrett?
4 out of
52, there's 52 cards. Casey, what's the probability that you're gonna draw a queen? No, how many queens are there?
No, 4.
4.
No, sorry, I was preparing something.
So 4
I got this.
out of 52 again. So we add those together.
Yeah, it's
we
eight
get
out of 52.
8 out of 52. What does that reduce to?
I have no idea. It's a number. It's a pretty
1
fancy number.
over.
No, it's not 1, because they said
Two.
2,
2 over.
4, 40. I don't know.
How many times does 4 go into 52? 4 goes into 8 twice, how many times does it go into 52?
10, just kidding, more than 10.
More than 10.
12, no, 12, 13, 14.
4
Okay.
into 52. No, we're gonna put it up here. How many times does 4 go into 12? 3. So it's 13.
I
213.
love how I was close. We said 12, no. I skipped 13 entirely, it's
Yeah.
14.
Yeah, you did. Okay, next question. What's the probability that you're gonna draw a red card or a king? Julia, are these events disjoint or overlapping? Overlapping, good, why? Why are they overlapping, Julia? They can occur at the same time. A card could be red, you could have a red king. So we have to use the complicated formula. It's not really that complicated, you just have to remember to subtract the overlap.
It's just called the complicated.
It's just longer than the other one. When I took my first statistics class, which wasn't until college, I had trouble remembering to subtract the overlap. I just remember getting all these problems wrong and thinking, what am I doing? And it was because I kept forgetting.
I don't remember ever doing this.
Really? Maybe you did, depending on when. I mean, I went to college fairly recently,
Yeah.
so. Statistics has come more in fashion now. Like when we were in school,
Right.
they didn't teach statistics.
No.
We didn't learn
I
that.
didn't
Time
have
out.
statistics till my master's program, I didn't have it in college.
Yeah, yeah, I didn't my first time around either. I
Yeah.
never took a statistics class until I went back to school the second time.
Yeah.
Time out.
Yes.
When do you use this in life? I'm curious, what would
You
you use this
actually
for?
use probability a lot. I
Right.
drive my kids crazy because we play games all the time and I'll be like, what do you think the probability is of rolling a 3 and a 4?
I mean, like, in the work, not having your mother
Well-
make a probability play a board game.
Yeah, I know. But in the real world, like you'll see a lot of data and you'll see a lot of things about probability. Like you'll read a newspaper article that says, you know, the chances of this occurring are this %. And you kind of have to know how they come up with their data and what it really means.
Yeah, and it's like a prediction
Mhm.
based on facts.
Like predicting who's
Like the
gonna win the
probability
next
of you-
election, those kinds of things are all probability.
Super Bowl.
Winning the lottery.
Lottery. Yeah, I should put
Yeah.
some lottery questions on here.
Lottery.
Okay, so first, event A is drawing a red card. Olivia, how many red cards would there be in a deck of 52? There's only 2 colors, right?
Spades.
No, we're just talking about red cards.
Yeah, but there's a black one.
There's the 52.
Oh, diamonds and hearts, I couldn't remember.
Oh,
Just say half 52. I don't know what it is, but it is. Half a red and half black.
half and half, so what's 52 divided by 2?
Hey, what's,
You can use your handy dandy calculator.
mine's in my pocket, I'm lazy. Yeah. Why did we
26.
figure that out?
So
We're
the
sitting here
probability
like
of drawing a
24?
red card is 26 out of 52. Julia, what's the probability that you're gonna draw a king? 4 out of 52. Now, what's the probability that you have a red king?
2 out of 50.
2 out of 52. So we counted those red kings twice. We counted them when we counted the red cards, we counted them again when we counted the kings, so we have to take them away. 26 plus 4 is 30.
28.
Minus 2 is 28. What does that reduce to?
God dang, I was hoping you were gonna say, what does that reduce to? 'Cause I don't know, it's a number, Garrett. 252 divided by 28.
4 goes into both again. I'll keep
Oh.
going. How many times does 4 go into 28?
Oh my
13.
goodness, guys.
13.
Seven.
It was.
Seven.
Seven.
Thirteen.
We already figured out
13.
4 goes into 52. Yeah.
I was doing the bottom one.
Oh,
Well,
well,
then
you
the
were right
top.
with 13 spot. Good.
So don't think I'm stupid now.
Okay, one more on here. What is the probability that you're going to draw an even number or a jack? First of all, are these events disjoint or overlapping? Disjoint. It can't be an even number or jack
And a jack.
because a jack is not a number. So we get the
Exactly.
easy formula.
If you're playing blackjack, it is the number.
Yeah, they are considered as numbers in some games. We play a game called Five Crowns, and in Five Crowns, they do have numerical values, but this is just standard
I'm
cards.
just gonna abbreviate and put DJ.
Okay. DJ or OL. Okay, so what's the probability that you're gonna draw an even number? Think about this, because it's not gonna be split half and half, because you don't have all numbers.
Okay, what is it? You're drawing an even number.
Even number.
20 divided by 2 is 10. So the chance of getting an even number is 10. Well,
Wait a second, where'd you get the 20 from?
I don't know.
How many number cards are there? Remember, there's
There's
4
two of them.
That's
suits.
40.
It's 40, so how many of those would be even? Half, which would be
20.
20.
So 20 out of 52.
Oh, see, you're right.
20 out of 52.
That's funny.
Plus, what's the probability of getting a jack? We've done a bunch of these. 4 out of 52.
Is it 20 out of 52? Is there a 1?
The ace would be considered.
Oh,
one.
okay.
Mhm.
Well, that's what Libby and I were talking about.
It would still be the same number of evens, you'd have 2, 4, 6, 8, 10, you'd have 5.
I think you should
Times
really use
4
Uno.
would be 20, because you have
This
4
one.
suits.
A lot easier.
Yeah, we all have more experience with Uno, I guess. So 24 out of 52, all right, guys, reduce this.
24, 52.
I
2 can go into 24 12 times, and 12 can go into 6, and 2 can go into 6 3 times, so that's 3, and 13. I don't know.
Wait, whoa, whoa, whoa.
How about 3 over
Just
13?
go backwards here. No, how many times does 4 go into 24?
It's 8 times.
6.
6 times, 7
Six.
times. 11 times.
Six.
Okay.
4 times 6 is 24.
We're
4
trying our
times,
best.
what is the 52, you should know this one.
13.
13, okay.
Yeah, 6
All
out of
right,
13.
so 6 out of 13.
That's a-
Okay, we're gonna stop here on this for today.
I was drilling, I was trying.
Oh,